Okay, so here is the tutorial on how to do a hard Atwood problem. I decided to make this one especially fun and added a block on top of a block here. For purposes of this problem, you may assume that there is some sort of like connection here so that this block is not really going to go anywhere. It's going to be stuck to the 2 kilogram block. So it's a matter of just figuring out what its mass is. So we need to find this first tension here in this first string. We need to find the tension here in the second string. And then lastly, we need to find the missing mass right there. This is really no different than a lot of problems you've already done. So let's just go ahead and get into it and give it a whirl. So we're going to start by trying to figure out what T1 is, and we're going to do that by isolating around this object right here. So if we do that, what you'll see is we draw the free body diagram. You'll have to pardon my bad handwriting here. The computer doesn't write real nice on the computer. But anyways, we're going to have a force of gravity. We're going to have T1 going up like that. We do have the acceleration, and it is up in this case. And for this side, up is positive, so that's 2.61. That's meters per second squared. The force of gravity would just be mg, which in this case would be 4 times 9.8. So that is 39.2. And that's going to be negative. And so all we really need to do at this point, and let me scroll this down a little bit, is we just need to run it through the second law problem to figure it out now. So now we just need to do F net equals ma, where the mass is 4, acceleration is 2.61. Let me grab the calculator and punch that in real quick. And we get 10.44 newtons, and it'll be positive. Then we know that F net is equal to Fg plus T1, which is equal to 10.44. We know that Fg is a negative 39.2 plus whatever T1 is. So we solve for T1. T1 comes out to be 49.6 newtons. So if we go back up here to my chart, I can just go ahead and put in 49.6 newtons right there. Okay, now let's figure out what T2 is. To figure out what T2 is, let's isolate around the 8 kilogram mass. And when we do that, we get our free, I'm going to draw the free body diagram right here. Now remember, on this side, since it's going clockwise, down is the positive direction. So Fg equals mg, which is 8 times 9.8. And we get 78.4 newtons. And in this case, that is a positive because it is down. And then we're also going to have this T2 going up here. And we don't know what that is, but we do know the acceleration is down at 2.61. And so now it's just like we did just a second ago. F net equals ma, where the mass is the acceleration times 2.61. And so we get 8 times 2.61, and we get 20.9 as the newtons there. Again, that's positive. And so now we just solve for the missing force the way we've done it so far. Fg plus T2. Let's move, get a little more room here. And when we start plugging stuff in, we get a positive, positive 20.9 is equal to a positive 78.4 plus whatever T 2 is. And so when we calculate that, we get negative 57.5 equals T2. So if we come back up here, now we know that this is 57.5 newtons. Now, if we want to figure out this last one, all we really need to do, because it's attached, we can treat the two masses as just one big mass that we don't know what they are. And what we'll do is whatever we find at the end, we'll just subtract 2. So what I'm going to do is I'm just going to isolate around the whole thing. And if I do that, what I end up with is some unknown mass being pulled this way. This would be T2, and it's 57.5 newtons. And we'd have T1 going back, which would be 49.6 newtons. And we know we're going to have the acceleration that way at 2.6. Excuse me. We're going to have this at 2.61 meters per second squared. So if we just do an F net equals T1 plus T2, we will get real quickly 57.5 minus 49.6. And so when we do that, 57.5 minus 49.6 into the calculator, we get 7.9. So that means F net is 7.9 to the right. We know that this is equal to the mass times the acceleration. So 7.9 equals this unknown mass times 2.61. So if we divide that, we get the mass is equal to 3.03 kilograms. Or really, it's 3 kilograms. So if we go back and we look at our drawing, if the total mass is 3 kilograms and 2 kilograms is this box right here, that means that that box right there must be 1 kilogram. So there is my answer. You'll have to pardon me for not doing sig figs.